Okay, optimization, everybody's favorite thing. So a few things I'm going to tell you about that, and I'm going to stop talking in a minute and you're going to write this down. But I found some more information at ehow.com. It's just how to solve calculus optimization problems. It kind of gives this list again. Again, this isn't something you need to memorize word for word. It's just helping you as far as how do you set up problems when you don't know how. So you're going to stop this, and then you're going to write this down. And I'm going to continue scrolling down. Okay, so these are the ones that are sometimes they're not really the most realistic real-world problems. So in this one, it's talking about a manufacturer wants to design an open box. So think about a shoebox without a lid on it, having a square base and a surface area of 108 square inches. What dimensions will produce a box with maximum volume? So in optimization problems, you're trying to optimize. You're trying to find the biggest thing, or in some cases the smallest thing. So mins or maxes of a particular equation. In this case, I care about producing a box with the maximum volume. That's what I'm choosing to optimize. So if you go through this step, it can kind of help you organize some stuff, but I'm going to go through it and just think about this is what my thought process does. So I'm thinking about, okay, what dimensions will produce a box with maximum volume? So be prepared to be amazed by my skills, but you know, they're really good. This is an open box. The top is not on here. If I want a box with maximum volume, when I'm trying to find a relative max, I take the derivative of that thing. That's the thing I'm taking the derivative of. So I need to set up a volume equation first. It has a square base, and it has a surface area of 108 square inches. Okay, so those things seem like they would be important, since the surface area never changes, and it has a square base. So what I'm going to do is I'm going to think about this in terms of volume is length times width times height. But if I have something that's like this, and it has a square base, that means two of these dimensions are going to be the same. So instead of length times width times height, I'm going to say width times height. Or I could say v is equal to w squared times h. Okay, so far so good. The problem is I need to take the derivative of this thing. So I would get a dv dt, a dw dt, and a dh dt somewhere in here. And I really don't want all that stuff. Like, I don't have that much information. So somehow I need to get this into fewer variables. I have w squared already, so what I'm going to do is I'm going to figure out, okay, well, how about if I could get rid of h? This is where this part comes in. The other information helps you get rid of one of the variables. So surface area of 108. So the surface area, you can say a, you can say s, you can say whatever you want. Think about it in the bottom. So if this is WWH, WW will produce an area of length times width, or W times W. So that's the bottom of the box. That's the area of the bottom. Plus, now I need all sides. I have W times H. Over here, I would have H times W, W times H times W. So I would do that 4 times. And I know I have a surface area at 108. So I know I've got 108. And again, over here, I could substitute for W, or I could substitute for H, but here, it's harder for me to substitute, to take out a W than it is to just solve for H. So what I'm going to do is I'm going to subtract 4WH, and then I'm going to divide. And I've got H is equal to 108 minus W squared over 4W. So volume is equal to W squared, and I'm going to fill in this. Once I do that, I can begin to take the derivative, but this looks like it's a little bit more difficult to take the derivative of than I want it to be. So I'm going to simplify this as much as possible. 108 divided by 4W would be 27. 108 divided by 4 is 27. over W minus W squared over 4W would be W over 4. I'm going to distribute this, just so again I make it easier on myself before I take the derivative. So 27 over W times W squared, one of the W's would cancel out and be left with 27W minus, and I can rewrite this as 1/4 W cubed. Okay, so far so good. I know that you're super excited about this now. But this is my volume. What I need to do now is I need to think about, okay, well, if I'm optimizing this, if I'm thinking about a min or a max, and it's happening where I need to figure out this out, so it's for any one of these things, what I'm going to do is find the derivative so that I can find out, is there a maximum? So, if I take the derivative, v, v prime, and you don't really have to do dw dt's, dx's dt's, dh's dt's, you just don't want to have more than one variable at a time. So in this one, because I can do this in terms of w, so this would be like volume with respect to w, so we're good without doing more. I can say v prime is equal to 27 minus 3 times 1/4 is 3/4 w squared. What I want to do is I want to set this equal to 0 and solve. Multiply both sides by -4/3. I get 27 times -4/3. 27 divided by 3 is 9, times 4 is 36. That should be right, yeah. 36 is equal to w squared. You take this, you should get 6 is equal to w, or -6 is equal to w. But we're talking about a width, so it doesn't make sense for this to be negative. So I have 6 is equal to w. Okay, so then the next thing that I do is I think about, what is this one? Oh, I think about, is this a min or is this max? If this is my w and this is my v, and I'm going, I can't have less than 0, so I've got 0 to 6, 6 to infinity. And I put in a value between 0 and 6, and I figure out, well, what is going on with my, I should have the derivative there. The derivative actually changes from positive to negative. So you can take my word on it, or you can put in the value of 1 somewhere over here, and you can see 27 minus 3/4, so it's going to be positive. 6 to infinity, you put in a positive value in between those, and you're going to get a negative v prime. So I see positive to negative, which means there's a relative max. So in this one, what dimensions will produce a box with a maximum volume? So right now, I know my width is 6, and I have to be careful about what units this is. If the surface area is square inches, the width would just be 6 inches. And I also can now figure out the height. So I go back over here, and height was 108 minus w squared over 4w. So my height, if you put that back in and you say, okay, well, what happens if you get 6 in there? You should get a height of 3. Be really careful about what it's asking you now. It's asking you what dimensions will produce a box. So I need all 3 dimensions. I need length, width, and height, even though these two are the same. So I'm going to say 6 inch by 6 inch by 3 inches. That's what's going to produce the maximum volume. What is the maximum volume? You actually have to figure that out. Volume is length times width times height. In this case, w times h. 6 times 6 times 3. Volume is 6 times 6 times 3. So 36 times 3, which is 108. It's just a coincidence that this is the same thing as surface area. Inches times inches times inches is inches cubed. For those of you who like geometry, now's your time. For those of you who don't, you've only got a couple more months till you're out of calculus. So, that's this one. Welcome to optimization. You're going to love it.